we can go further, right? We can put these two separate people, these two separate person objects inside of an array. Remember how I talked about arrays in the previous video? We can define any array by saying person, or whatever the type of the array is, what the kind of array it is, square brackets, and then array, or name of the array that has these variables, and we can define it like this, where we write person, person2. There we go. So we have an array of person, right? And there are two elements thus far, person and person2. And let's get rid of this. I have an idea. We can cycle through this array of person. So for int I equals 0, I is less than array.length I plus plus. So I is a shorthand for writing count or iterator. It keeps track of the number of iterations the loop has gone through. And we're going to run this loop basically for the entire length of the array. So while I is less than array.length, we keep adding 1 to the variable I, and then we keep executing the body of this array. Body being defined by this curly bracket. So within the body of the array, what are we going to do every iteration of the loop? We're going to say system.out.print line, and we're going to write in it because we're interacting with this array, we have to interact with the current element of the array that we're messing with, right? So we can say array I, right? So what this means is select the current, we're going to select an index, a specific index of the array, and the index is defined by the current iteration of the loop. So if this is the very first iteration of the loop, it'll be equal to 0. I will be equal to 0, and thus we'll be interacting with the 0th element of the array, which is in this case person. And then the next iteration will be 1, and we'll be interacting with 1th. 1th? Is that a word? We'll be interacting with that iteration, with that element, excuse me. So we go a little bit further though, because we're at this point, array I is roughly equivalent to just saying person in this case, but I'm going to say array I, and then we want to specify, for example, the instance method that we're messing with. So say get name. And we're going to also get their age. We're going to print them out. So let's do that. Roberta, Arnold, 75. So we just went, so we really wrote a blueprint for person. And then this loop is also kind of like, it defines like what's going to happen every single iteration of the loop. And what it's going to do is going to get their name, going to get their age, based off of index of the array, and we figure out the index. The index is just based off of the iteration of the loop. So that's how we're able to, in effect, cycle through every element of this array. Very cool. Very cool. We could add more elements to this array. We could say, comma, new person, 66 Frederick. Oh, well, we don't want to put a semicolon there because we're actually inside of an array declaration. And we could say another person. Now, notice there is a slight problem, or really it's not a problem, it's more of an oversight. What if we didn't want to define their name yet or their age yet. What if their age changes? How do we do that? Well, we'll get into that in a little bit. So, for example, if we want to deal with the fact that we don't want to enter their name immediately, or maybe if we only have let's just write 34. See though that it complains. It says the constructor person int is undefined. There is no constructor for this class of person, which takes only one argument. So if we go back to person, we'll see there's person, int age, string name. Well, that's a problem. How do we deal with this? How do we deal with the fact that we only have one? We create another one. We create another constructor. We say person, int age, and we say this age equals age. Now, what do we do about name? We haven't been given name. Should there just be a default name? Maybe. I don't know. Anyway, now we have this situation resolved, but what if we want to add a name at a later time, for example? Well, that's where we'd want to create a setter, right? We set a value belonging to the person. We set an attribute to the person. So to create a setter, you say public void, because you're not returning anything. And you say set, and then the name of the attribute you're trying to set. In this case, name, set name. And of course, you have to specify an argument in order to change anything, to enact change. So say string name. And then in the body, because we're not returning anything, remember what we're doing is changing the value of this name right here. So kind of like what we did here, we're going to say this dot name equals name. That should work. So now if we go back to entry, we can see, for example, up here, if we write person dot set name, we change the name. And of course, whatever is true here, we could also do it here, but we'd have to say like current iteration, say something like set name. How do we make it so that we change only the names of those who don't already have a name? How do we do that? Well, we say we create an if statement, right? Every iteration of the loop is going to have this if condition, but only one iteration. Don't advance. Only one iteration is going to have this situation where a person doesn't already have a name. So if array I get name, if that is null, that is, if there is no name or its value is null or whatever, then we're going to say array I set name, and then we'll put in quotations whatever we want to set this name for that one person. So otherwise we ignore it and keep going. So actually, let's move these print line statements after the if statement, the loop. It's still part of the loop. Let's see. Right. Start of for loop. Within the for loop, we check to see if the name is null. If it is, then we set the name to Isaac. And regardless of the outcome, we're going to also print the name and the age. All right, so let's run. Roberta, 5, Arnold, 75, Frederick, 66. And you'll notice we don't get feedback, but we know this we know the if statement worked, because then it prints out Isaac. So we were able effectively to use set name. What we have explored also here isn't just object-oriented programming, but also this concept called encapsulation. What is encapsulation? Well, person has a name of type int, but you cannot directly mess with age outside of person, because if we try to mess with it, we'll find that it's not visible to anyone outside this class. So we have to use a set age if we want to affect age, or we'd have to use the constructor here, right? And the same is true of name. If we want to change name, we cannot change it directly. We have to use this setter, this setter method, this instance method, where we change the name to whatever we specify. This concept is called encapsulation. We have encapsulated name, right? There is kind of a wall, a barrier that prevents people from directly messing with name. And if people want to mess with name, they must only use the method that we've specified they should use, the encapsulating method, the one that protects it. Okay. And it might not seem especially obvious now, but we actually have a lot of control here. We can do a lot with set name. Now, in addition to controlling the flow of information into our class here, we can also, like, for example, have it so that set name also tells us when we change the name. Like what I'm doing here. So if I run the program, I'm going to see Roberta, 45, Arnold, 75, Frederick, 66. Name changed. Then Isaac, 34. So that's one of the benefits of encapsulation. You can create conditions within this method. You can do all sorts of things. You can have, like, even passwords. You can have password systems. You can have all sorts of complicated designs for your programs that take advantage of encapsulation.